Hi everyone, our project focuses on flight delays and cancellations, which are becoming much more common as air traffic increases. And these delays have been causing major disruptions in cost to the US economy for over $30 billion each year. So we're going to be building a model that uses these flight, airport, and weather data to predict travel disruptions and specifically how long a flight is expected to be delayed. So for our literature review, we discovered that past research has used both traditional and deep learning models to predict delays, and research has improved recently in their performance using newer methods like the bidirectional long short-term memory network, as well as transformers and graph neural networks. And these models have definitely helped track down how delays spread across flights. For our dataset specifically, we're going to be combining several ones, including BTS on-time performance, the global weather data, Kaggle airline delay data, and OpenSky flight paths, which will give us access to both US and global flight information, and we'll be using that to train and test our model.
Flight delays are increasing in both severity and frequency, but many of them can be predicted using known factors like weather, airport congestion, and scheduling. With access to historical flight and weather data, our goal is to build a machine learning model that predicts the expected delay time for a flight using regression, as well as providing a cancellation probability. This approach can help both passengers and airline operators make better decisions ahead of time and reduce the impact of disruptions.
We'll first start by cleaning and merging the datasets into a standard format. We'll use dbSCAN clustering and TSNE dimensionality reduction to visualize the data and check for bias or noise. Then we'll engineer features like day of the week, departure time, airport, and weather conditions. We'll also discretize delay times into 15-minute time buckets to help with interpretations. For models, we'll use linear regression as a baseline, followed by a random forest and a transformer-based model. Each will be trained to predict delay duration using the features we extract.
So we plan to use a combination of both classification and regression methods, and in order to analyze the success of both of those, we are going to be using metrics such as the accuracy score, which is just the overall accuracy, the F1 score, and the mean absolute error. So we do have goals for all of those. The broad impacts of our model are going to be just improving sustainability efforts around the travel industry, reducing fuel waste, improving scheduling of airports. Different ethical considerations we want to keep in mind is monitoring biases in our data sets as well as algorithms, and also we do expect the transformer-based models to provide the most accurate predictions in classification and delay estimation tasks compared to the traditional ones.